Alright, so in this tutorial here, we're going to be looking at doing a gas collection experiment. Just let me walk you through the setup here. We have our compound here. The compound we're testing this time is cupric carbonate. It's starting off here as a solid. This one here actually undergoes thermal decomposition. So upon heating, it actually releases off one gas. Because we are a closed system here with this stopper lid here, I'm hoping that that gas is going to travel through the top here. It's going to travel through this rubber hose here into this basin of water. The basin of water here is about half full here. The end of this rubber hose is actually in the opening of this gas collection tube. You can think of the gas collection tube here as like a barrette. This one here is also a 50 milliliter gas collection tube. We have a 0 mark up here. We have a 50 mil mark down here. We can actually track changes in volume as we go through. At the moment here with our setup, I filled up this gas collection tube, fully filled with water first. I covered the top, put it into the bin. The water pressure here is actually enough to actually keep the water in this gas collection tube. The hope is as the reaction proceeds, as the gas actually bubbles into the collection tube itself, that gas is going to take up some volume. It's actually going to push the water out. So what we can do here is, because we have a way to actually track volume here, you can actually track sort of how much volume is collected in a certain time interval. You can actually measure rate of change this way. For this lab here, we're going to be verifying the ideal gas law. So what we're going to do is we're going to let the reaction run for about half, just to make sure any leftover gas bubbles here make it all the way through. I can turn on and off the reaction by pulling the Bunsen burner close for that thermal decomposition or taking it away. I do want to make sure that I'm sort of within the 0 to 50 mil mark here. If I bubble too much gas here, I need to start over. I don't have a good reading of volume. For pressure, you would need to look at sort of barometers here. You can assume 1 atmosphere pressure for now. Ideal gas constant we always know to be 8.31. The temperature you can look on a thermometer. Just make sure you convert that to Kelvin before you start. And then in terms of the moles, we can actually get it from the mass. We have a starting mass to begin with. As I heat it up, the reaction is going to happen. The only mass loss is going to be due to the gas that's actually being escaped. So if I measure the mass before, measure the mass afterwards, by doing a subtraction, I can figure out the mass and therefore the moles. So let's just strike this Bunsen burner here. So just be careful as you're holding this Bunsen burner here. I'm going to put it beneath this Erlenmeyer here. Let a little bit of this powder here start heating up. Again, it's a thermal decomposition. You already start seeing the gas bubbles actually forming there. Okay. Again, if I have a very steady amount of heat here, you can track that as actually a reaction rate, change in volume versus change in time. Okay. So I'm just going to let this keep heating for a little bit here. Qualitatively here, this powder here would actually start darkening in color as well. Okay. So we have a fairly steady rate there. Okay. I'm about halfway there. I'm going to pull off the heat source. Okay. Turn off the Bunsen burner when we're not using it. Okay. That way we let the leftover gas here travel all the way through. I just want to double check that I'm between the 0 and the 50, which it looks like I am. And at this point here, I take a volume reading there, and we can do the ideal gas law to verify the molar mass of this gas that we've actually trapped inside there. Okay. Things that you can play around with in this setup here, you can play around with the amount of powder to begin with. Sometimes these rubber tubing here may actually be different diameters, so if it's too narrow, sometimes the gas has a hard time actually going through. You can actually play around with sort of which diameter they're using, maybe the length of the gas tube, maybe the pressure or the temperature of the system here, but a lot of things you can play around with. What you want to do here is, because this one here would be cooling down very quickly here, it's going to cause a little bit of negative pressure. When we're done reading the volume here, we should be pulling this, the open end of the rubber tube here out, just in case that there's no suck back here. Just make sure that all the gas here, right now the gas is trapped in, it's pushed off a bunch of water here, and we can take that volume reading there. Okay? So if you have any questions, just let me know. Thanks, guys.